All right, welcome to The Explainer. Today we're going to pull back the curtain on the secret boss that's running things inside every single one of your devices. I'm talking about the unsung hero of all of computing, the operating system. I mean, think about it. When you click that mouse, type on your keyboard, or tap on your phone screen, who's really calling the shots? You might think you are, right? But nope, there's this super powerful middle manager in there doing all the heavy lifting for you. And that's it right there. The operating system, or OS for short. You can think of it like the conductor of a really complex orchestra, that orchestra being all the hardware inside your computer. The OS is the one making sure every single piece, from your processor to your printer, is all playing together in perfect harmony. So, what does this conductor actually do? Well, it really boils down to two main jobs. First, it acts like a traffic cop for all your computer's hardware. It's constantly managing resources, deciding which program gets to use the processor, when and for how long. And second, it's what creates the world that you and I actually see and interact with. The windows, the icons, that little cursor. It provides all the services that let us actually get stuff done. Okay, so to really get how incredibly sophisticated this whole system has become, we've got to go back, way back. The story of the OS is basically a history of solving one problem after another, starting with these absolute giants of the past. So let's set the scene, right? We're talking about the early days of computing. Computers are these massive, room-sized behemoths, and you couldn't just, walk up and start using one. The very first operating systems were designed to solve a pretty basic problem. How do we efficiently feed jobs to these giant calculators without wasting time? The answer they came up with was something called batch processing. It worked like this. You'd get your job all ready on a punch card, then you'd physically hand it to a human operator. That operator would then collect a bunch of similar jobs, group them into a batch, and then feed that whole stack to the computer at once. It was slow, and you had zero direct interaction with your program while it was running. You just had to wait and hope for the best. So yeah, there was a huge trade-off here. I mean, on the one hand, it was a pretty efficient way for lots of people to share one giant expensive machine. But the big drawback, the CPU, the actual brain of the computer, spent a ton of time just sitting there, waiting. Waiting for a slow tape drive or a card reader to do its thing. All that wasted time, all that wasted potential, that became the critical problem that absolutely had to be solved. And that's what drove the next big leap. All right, so the big challenge was clear. How do you solve that idle CPU problem? How do you keep that super expensive processor busy, like all of the time? The answer, it turns out, was to teach the operating system how to juggle. And the brilliant solution they came up with was called multi-programming. The idea itself was actually pretty simple, but it completely changed the game. Instead of just loading one job into the computer's memory, you'd load several at once. Then, the very instant one program had to stop and wait for something slow, like reading from a tape, bam! The OS would instantly switch the CPU over to work on a different program. And just like that, wasted idle time became a thing of the past. Now, this was a massive leap forward for the computer's efficiency. But from the user's perspective, things hadn't really changed all that much. You were still just submitting one job at a time and waiting for it to finish. The computer was doing all this fancy juggling behind the scenes, but from where you were standing, you couldn't see any of it. Which, of course, brings us to how we use computers today. I mean, we never do just one thing at a time, do we? We totally expect our computers to keep up with our, let's be honest, pretty scattered brains, handling dozens of different tasks all at once. And that leads us to the next big thing, multitasking. This is where the real magic starts to happen, at least from our point of view. It takes that behind-the-scenes juggling from multi-programming and basically puts the controls right in our hands. The OS switches between your web browser, your Spotify, and your Word doc so incredibly fast, it creates this powerful illusion that everything is running at the very same time. This is without a doubt the foundation of every single modern device we use today. Okay, so we've squeezed every last drop of efficiency out of a single processor. So what's the next logical step if you want even more power? It's pretty simple, actually. Just add more processors. And that's called multiprocessing. And this is a really important distinction. See, multitasking is a super clever trick, right? It's an illusion of doing multiple things at once. Multiprocessing, that's the real deal. When you have more than one CPU, the computer can literally execute multiple instructions at the exact same time. We're not juggling anymore. This is true, honest-to-goodness, parallel power. So how do we actually do this in the real world? Well, instead of trying to cram a bunch of separate processor boxes into a computer, engineers figured out a way to put multiple cores, which you can think of as complete mini processors, all onto a single chip. So when you hear about your quad-core laptop or your octa-core phone, that's what they're talking about. It's a little multi-processing powerhouse. And the benefits here are just huge. First off, you get a massive increase in throughput. Simply put, the computer can get more work done in less time. This is crucial for things like high-end gaming or editing 4K video. And second, you get a big boost in reliability. If one of those cores happens to fail, the operating system can just hand its tasks over to the others and keep on chugging. Now, of course, not every computer is a laptop on your desk or a phone in your pocket. Some computers have incredibly specific, often high-stakes jobs to do, and for that you need a specialized operating system to match. For example, you have a network operating system. Its entire purpose in life is to help computers talk to each other and share stuff over a network. Every single time you open a shared file at the office or just browse a website, you are interacting with a powerful network OS running on a server somewhere out there, making that connection happen. And then there are real-time operating systems, or an RTOS. With these, it's not just about getting the right answer, it's about getting the right answer on time, every single time, without fail. We're talking about the computer that controls the anti-lock brakes in your car, or a medical device like a pacemaker, or even a surgical robot. A tiny delay isn't just an annoyance, it could be the difference between life and death. So wow, we've gone all the way from punch cards to literal life-saving robotics. Let's bring this all back home and look at how all these ideas come together in the devices you and I use every single day. You know, this quote from the source material we looked at really nails it. It says, "The operating system hides the complexity of hardware and presents a beautiful interface to the users." And that's exactly it. The whole point of a modern OS is to wrestle with all that insane, complicated hardware stuff in the background so that we just get a simple, clean, beautiful way to use our technology. And these are the big players that do just that. Whether you're on a computer running Windows or Mac OS, or maybe you're a Linux user, or you're on your phone with Android, you are using an incredibly sophisticated, multitasking, and almost certainly multi-processing operating system every single day. All of these are the direct descendants of those early, clunky batch systems. So when you look at the whole journey, from a system that just crunched through a stack of cards to one that connects billions of us in the cloud, it's clear the OS has always evolved to solve whatever the next big challenge is. Which leaves us with a really interesting question, doesn't it? What problem will the next generation of operating systems be designed to solve?